Hello everyone. In this lecture we will discuss about one of the major techniques used in data warehousing, which is dimensional modeling. So what is dimensional modeling? Why we use dimensional modeling? We will discuss in this lecture, but before going further, let's take a review on why we move towards dimensional modeling. So to look at that, we have to go through relational modeling first. So what is relational modeling? Relational modeling is to develop a logical modeling model using ERDs. But where were ERDs were used before the invention of decision support system? So the relational modeling was used to develop OLTP systems. We discussed about OLTP system in our previous lecture, but for the record, an OLTP system is a system that is used to record transactions. It is just like an ATM machine. So why an ATM machine is used? It is used to uh, withdraw money by the users, by the customers. And when a user withdraws a money, a transaction is made and recorded in the decision supports sorry, in OLTP system. So OLTP systems are used to record our transactions. Now relational modeling was used to develop OLTP system. Now OLTP system are predefined in a way. What is predefined in this matter? So predefined is that, let's say we say that our OLTP system will record the transactions data. Our OLTP system will generate this report. Our OLTP system will generate that report. So this kind of scenario, this kind of requirements, we are these are already predefined for an OLTP system. So there are focused queries that run on an OLTP system. What are focused queries? Focused queries are those queries that are already defined, that these queries will be run against our OLTP system. And these queries actually access only a smaller number of rows in our database. So again, OLTP systems are very good at accessing a small number of rows in our database. So, and another point is OLTP systems were fully normalized. Now I already discussed OLTP system is made up using relational modeling and ERD techniques. So when we develop a database using a relational model, we try to make it fully normalized. Why we make it fully normalized? Because we want to remove any duplication of data and any inconsistencies of data, and we want to actually avoid or prevent any kind of anomalies in data. We have discussed about different anomalies of data, like update anomalies, like deletion anomalies, like insertion anomalies. So in order to avoid these kind of anomalies, we actually build our system that is fully normalized, and that is done in OLTP systems. Now when were decision support systems or data warehouses were introduced? Now the very big difference between an OLTP system and a data warehouse or a decision support system is, so the very big difference between an OLTP system and a decision support system, that OLTP system are used to record that or store the transaction, but decision support systems are used to analyze those transactions. So you see the difference there is, the OLTP systems only records the transaction, it does not analyze them. But decision support systems are used to analyze those transactions so that the business owners take their decision using the analysis of the data. Now, when OLTP system were actually modeled using relational models, when the decision support systems came into being, uh, again the decision support system are used to analyze the data, so the queries are not focused. And here not focused means the queries are actually uh, looking at the larger part of the database. It means that they will access a larger number of tables inside a query, and when they will look at different tables and will try to get data from these multiple tables, the decision support system will need to join these tables and get the data. And actually when they will get the data from those tables, they will try to aggregate that data. They will try to get the summation from that data. Let's say they wanted to see the number of sales according to the region, and they are also wanted to say the number of sales according to the product in some region. So the CN support system will try to analyze the data by making the joins between multiple tables, and will try to aggregate the data, and after that they will try to sort the data based upon some columns. So there are number of operations involved inside a CN support system, and also there are number of tables. Actually the larger part of the database is involved to actually access the data and to process the data. So uh, OLTP systems that were fully normalized, they were used to uh, actually remove the duplications of data or inconsistency in the data, but the CN support systems are used to analyze the data. And in that manner, when they try to join multiple tables, the performance degrades if we use the OLTP relational model inside the CN support system. So if we use the relational model for the CN support system, uh, the performance of the CN support system for analyzing the data from multiple tables will decrease, because we are making a join between multiple tables, and when a threshold of number of tables involved in a join uh, passes, or it goes out of a threshold, the performance degrades. Why the performance degrades? Because it takes a lot much time to actually gather the data from multiple tables. That is not required from a decision support system. Decision support system are used to analyze the data, and their purpose is to provide the result in a minimum time. So when the performance degrades, it takes more time to get the data. So in order to avoid this, what we did uh, to improve our decision support system, so the statement written here is OLTPs were not good at performing the join on larger tables. Again, I discussed earlier, OLTP systems were designed to actually record the transaction, but not for the access of larger data. So decision support is why. So OLTP system for use for decision support system. First, the OLTP systems were used. Yeah, it means that the relational modeling were used to for the decision support system. The relational modeling was not good for decision support system. So what it did, it actually degraded the performance of the decision support system, because number of tables that were involved in such non-focused queries inside decision support systems uh, were very large, and when the number of tables inside a join are very large, the performance degrades. It means the query takes more time to gather and provide the results. So that problem uh, led us to another model that actually was good for the CN support system. And in that model, what we did, actually we look at the problem. The problem was the number of tables. So and we have to join those tables. So what we did in another model, that was dimensional model, we did as that we actually pre-joined multiple tables uh, before execution of a query. So when we pre-join multiple tables, if there are 10 tables, now when we pre-join the table were merged into 5 tables. Now there were only 5 tables available for the query. Now in this time the number of tables were reduced already. So when we try to execute the query on these 5 tables, so according to the new model, this query actually took very less time to actually give us the results. So that model was that we introduced for decision support system, what dimensional modeling. Now in our next slides we will discuss more about ERD systems, and then how we move from an ERD or relational model to a dimensional model that was used to actually support the decision support system. So far, we have discussed about OLTP systems and decision support systems. OLTP systems always use the relational model or ERD technique, but decision support system use another model which is called dimensional model, that we will discuss in our further slides. But here in this slide, uh, we need to look at the history, uh, how why ERD modeling was needed inside an OLTP system or in a decision support system. So we will try to discuss that with the help of an example, and we will try to explain this slide with the help of an example. And in this slide, the slide is saying that before the invention of databases, the Copal data processing system were used to actually record the transactions. Now I will try to explain it with an example. There is a company called Wabda inside Pakistan that actually provides electricity to whole Pakistan, and it actually provides the bills to of their electricity to whole Pakistan. Now, when we talk about the meter reading and we talk about the COBOL systems, and first, when the meter reader records the transactions or records the meter readings, he actually feeds that information inside a file. Now, how does he feed the information inside a file? He actually stores the customer name, he actually stores the date at which he records the transactions or the meter reading, and he actually stores the uh, address of the customer. And similarly, for the next month, he again record the same five fields: customer name, address, meter reading, date, and time. So for every each month, when he records that information, he actually is duplicating three fields: customer name, address, and the meter number. So these three fields are actually duplicated at each entry after every month, because at the end of every month, the meter reader actually records the information, and he stores the meter reading with these three duplicated fields. So if the meter reader has recorded a meter reading of a customer for 1 year, he will have 12 rows which will be repeating with three fields: customer name, address, and the meter number. The two fields that will always differ will be the date and the meter reading. So at this point, when we were using COBOL, the data was being recorded uh, in a duplicate fashion. Actually, data was recorded, but there was no technique like databases. So the COBOL data processing system were actually recording the data inside a file, and that file for each customer will have duplicate data for these three fields. Those three fields were actually again customer name, customer address, and the meter number. Now, with the COBOL system, there were data redundancies always available inside the file. So in the COBOL data processing system, when the transactions are recorded, there are redundancies always there inside the data inside a file. So when there are redundancies available inside a file, then there will be data anomalies when we'll try to update the data. So, I will talk about the example of the address of the customer. Now, if the meter reader has 12 reading for a customer for 12 months, so he will actually record 12 addresses of the same customer. The addresses might be same inside all the 12 records, but there are different instances of that address will be available, as there are different ways to store an address of the customer. So maybe the meter reader will store the address in different formats in these 12 addresses. So when the meter reader will need to actually update the address of a customer, firstly he will have to update at 12 different locations, and he will the main point here is that when the redundancy was available with COBOL systems, that redundancy leads to different anomalies, and we had to tackle those anomalies actually before the invention of the database. So what when the databases came, and Dr. Cord, who is the inventor of the databases, actually realized that when we bring the data from file to a table, we actually need to fetch all the repeating data, and we will have to put that repeating data inside a single entity so that the repetition have to be avoided. So in order to avoid the repetition, we have to make different tables from different entities. So when we will have different tables, and we actually now from one file we made different tables, so in order to get data from these multiple tables, we have to join those tables. This was the cost when we introduced the database. But these databases, or this the logical ERD model, was very good uh, in context of old DB systems, in context of recording those transactions, because in that context we actually eliminated the redundancy of the data. But uh, we have to make a trade-off between the data redundancy and the performance. Now when we made different tables from a single file, now when we have to bring that data from multiple tables, we have to join those tables. Let's say if we have two tables, and we have to make a join between two tables, it is just like a nested loop. Why it is just like a nested loop? Because when we try to make a join, each row from one table combines with every row of the other table with the matching condition. Now uh, if we look at the nested loop join, the outer loop's index runs one time, and the inner loop index runs for n time of for the inner loop. So for one index of the outer loop, and the inner loop runs n times. Similarly, uh, it means there will be n cross n uh, iterations for a nested loop. In case of a join, the similar case appears here. For each row from one table, it actually joins with all the rows in the other table. So if there are n rows inside our first table, and there are n rows inside our second table, so the number of iterations that will occur will be n into n, which is n square. So the number of iterations, if we have to join the two separate tables, we will have n cross n transactions, n cross n iterations. Let's say it will take n cross n time to actually get the results from the both tables. So what we discuss in this slide, which is saying that the need for ERD modeling, the need for ERD modeling was that in the COBOL file systems, data was always redundant, and with the redundancy, there were always anomalies available. So in order to avoid those anomalies, what we did, we invented databases and ERD model. And with the invention of the ERD model, or the logical model, we actually separated the data that was redundant inside a single entity, and other data that was linked to those repeated entities, we placed that data inside another entity. And in order to gather the data from these two different entities, we have to join those tables so that we can get the result from both the tables. And in order to get the results from both tables, we needed n cross n times performance to actually get the data from those two different tables. But again, the whole point of introducing databases was that we actually eliminate the redundancy. And we already discussed that relation models or ERD models are very good at handling OLTP systems, because OLTP systems are actually used to record the transactions and actually used to eliminate the redundancy. So in order to eliminate the redundancy, we can actually use ERD models or logical models or the relational models. So these are three different names for one single approach, which is a relational model. So in the previous slide, we discuss about what was the main issue with COBOL data processing system. The main issue was the redundancy. So in order to actually eliminate the redundancy, we invented databases, and inside databases actually we discovered about ER model. So ER model is very successful because what it does, it actually eliminates all the redundancy from the database. And how it how it does it, it actually creates a normalized version of a database. What is a normalized version of a database? The normalized version of a database is that each entity with repeating information is stored inside a single entity, so that the repeating information can be eliminated. So if the customer record was with the three attributes, customer name, address, and the meter number was actually repeating in the file, but inside a database table, it will be the customer record will be stored one time. So there will be a one single entity for those attributes whose values were repeating inside a file. Now there will be only one copy of that record. So a customer will have a one single entity, one single row for its personal record in a, let's say in a table called customers table. So in a customers table we will have three attributes. Will at least we will have four attributes, customer ID, which will be the primary key of that table, customer name, customer address, and the customer meter number. And in another table we'll have the customers meter readings, which will have uh, three attributes. Customer ID is a foreign key from the customers table, the date at which the reading was taken, and the third attribute will be the meter reading. So there are three attributes. Again, the customer ID as a foreign key, meter reading, and the third attribute will be the date at which the meter reading was recorded. Now these two tables are connected using a relationship, because if uh, a customer's meter reading is recorded at every month, so a customer can have multiple meter readings after each month. So if in a file system the customer reading was recorded 12 times inside a year, so there were 12 different rows available inside the file, in which the customer's information of like its name, address, and meter number was actually repeated. But inside tables, the customer name, address, and meter will be recorded one time, but the reading for each month will be recorded 12 times. Now this relation shows that a customer can have multiple meter readings. So, and this is a normalized version of a database which is in third normal form. So when a database is normalized, and I explained you the example, now there are no redundancies available. So very big advantage of using ER model is that we use normalized approach, and with the normalized approach our data redundancy eliminates from the database. And when actually our database is in normalized form, the data duplication does not occur. And when the data duplication is not there, there are no anomalies of data available. So if you want to change the address of a customer, you will not have to go to 12 places to change that address, but you have to go to single record of that customer and you can actually change the address. So only one record lookup is required to actually change the data. Similarly, if you want to delete the record of a meter reading, you have to actually delete one record from the meter reading table. Or you have to update, if you have to update the meter reading, you have to go to the meter reading table and you have to update one single record. You do not have to actually update that and record at multiple locations. So this is another advantage. With the elimination of anomalies, data will be in consistent state. So there you will not have to update at every location with the help of ER model. Now what we told you earlier, with OLTP systems, the main purpose of an OLTP system is to actually record the transaction, or actually to update the transaction. In order to update a transaction, you have to go to a particular record to update that transaction. So when you have to go to a particular record, you actually have to search for that record. And when we talk about searching inside a database, there is a single structure that is available inside a database is index. index helps us in searching for a particular field inside a column. So indexes are very useful inside OLTP system and with ERD model. So with the physical model, you can actually use indexes to actually search your queries in a faster way. So indexes are always available, and indexes are very good choice for searching for a particular row of a particular customer inside the database. So with all these reasons that are very useful for the OLTP systems, we can easily say that the OLTP systems were very good because they were using a relational model to actually record the transactions. So